Hello and welcome back to our series of videos that's looking at how we can answer some of these really challenging calculations that we have to do as part of the quantitative chemistry topic at GCSE. In this video we're going to be looking at ideas around concentration in order to tackle some tricky calculations. So let's have a read through of our question today. Calculate the mass in grams of NaOH, that's sodium hydroxide, that needs to be added to 50 centimetres cubed of water to make a solution with a concentration of 0.25 moles per dm cubed. And we've got our atomic masses to help us of sodium, oxygen and hydrogen. We're going to need to use those a little bit later on. But first of all, let's just remind ourselves about this unit for concentration, because even if we're not sure how to calculate concentration or how we use that in some calculations, there's a big clue in the units to help us. So the units for concentration is moles, and we've looked at how we can calculate moles in other videos. Moles per dm cubed. And so if you look at that, that dash, remember, means a divide, just like meters per second is meters divided by seconds when you're calculating speed. So moles per dm cubed we would calculate by doing the moles divided by the volume of our solution in decimeters cubed. So that's one of the calculations that we're going to need to be using, and we'll think about how we need to rearrange that in a second. So as ever, we need to bug our question to make sure we're highlighting and picking out the key parts of the question. Calculate, that's our command word. The mass, let's underline mass, in grams, so it's telling us the unit we should use, of NaOH, always underline the chemicals that we're using, that needs to be added to 50 centimetres cubed. So I'm going to circle my number and also underline centimetres cubed. That will be important later on. Of water to make a solution with a concentration of 0.25 moles per dm cubed. Let's circle that number. So the first thing that jumps out at me is that the units for the concentration is moles per dm cubed, but the unit for the volume that we've given is in centimetres cubed. So we need to remind ourselves of the conversion of centimetres cubed into decimeters cubed. So there are 1000 centimetres cubed in a decimeter cubed. So that means if we want to convert from centimetres to decimeters, we would need to divide by 1000. If we want to convert from decimeters into centimetres, we would need to times by 1000. Okay, so a decimeter, just to help you understand that, is 1 litre. So 1 decimeter cubed is 1 litre. Now in physics, you also look at volumes when you're calculating density in meters cubed. It's not something that we use too often in chemistry unless we're dealing with gas volumes, but that's something you'll look at A level. And so again, that's a factor of 1000. So in order to convert decimeters cubed into meters cubed, you divide by 1000. The other way, you would times by 1000. But we're just going to need this conversion on the left-hand side, centimetres cubed to decimeters cubed. So let's deal with that cheeky little conversion to start off with. Okay, so the volume that we are using, so the volume is, well, it will be 50 divided by 1000, because we're going from centimetres cubed into decimeters cubed, divided by 1000, and that will give us 0.05 decimeters cubed. Okay, now in order to calculate the mass of grams in sodium hydroxide, we need to know the number of moles of sodium hydroxide. Now, in order to calculate the number of moles using the concentration and the volume, we need to rearrange our equation here. So we want to get the number of moles by itself. So we need to get rid of the dm cubed on this side. So at the moment we're dividing by dm cubed. So if we times both sides by our decimeters cubed, times by decimeters cubed, that tells us if we do concentration times by volume, that will give us our number of moles. So let's apply that to our equation here. So the number of moles will equal the concentration, which is 0.25, multiplied by the volume, but notice the volume here is dm cubed, so we need to use the converted volume here, multiplied by 0.05 dm cubed. So let's put that into our calculator. 0.25 multiplied by 0.05. So that gives us a number of moles of 0.0125. Okay, but the question hasn't asked us for the moles of sodium hydroxide, it's asked us for the mass of sodium hydroxide. But we know from calculations that we've done before, the mass is equal to the number of moles times by the MR, the relative formula mass. We know the number of moles, we don't yet know the mass. To work out the MR, well, that's why they've given us the atomic mass at the top here. Okay, so the next one, MR, relative formula mass of NaOH, will equal, I'll just move down my camera slightly, will equal, well, we've got one lot of sodium, so 23. We've got one lot of oxygen, plus 16. And we've got one lot of hydrogen, plus 1. So on my calculator, we just need to do 23 plus 16 plus 1, which gives us 40. So the MR is 40. So in order to make a solution with the concentration of 0.25 and a volume of 50 centimeters cubed, we need to add in 0.0125 moles of sodium hydroxide. So the mass of sodium hydroxide, we go back to our second equation here because we now know the moles and the relative formula mass. The mass equals the moles, which is 0.0125, multiplied by the MR, which is 40. So we do in our calculator 0.0125 multiplied by 40, and that gives us our final answer of 0.5 grams. So let's just go through the question again just to check where we would pick up our 4 marks for this question. So we can see here we've clearly broken it down into 4 key steps. So the first mark is for that conversion of 50 centimeters cubed into decimeters cubed. The second mark is for working out the number of moles by doing concentration multiplied by volume. The third mark is for working out the relative formula mass of sodium hydroxide. And our fourth mark is by doing the moles multiplied by the relative formula mass to give us the grams of sodium hydroxide. So I hope you found this video useful. If you're doing combined science, that's all the videos that you need to worry about. If you are doing triple science, then I've got 2 bonus videos coming up for you that look at titrations and gas volumes. Well done everyone, I shall see you next time. Bye for now.